Okay, what is up, guys? I hope you're good. So in the PlayStation 5 video, I did mention that I was working on this laptop and how I was gonna record a video because it's kind of a difficult repair. So I've just finished with the PlayStation 5 and it's close. It's right next to me. Should I plug it? No, it's fine. It's okay. I'm not gonna plug it. Anyways, so this is a Dell. What is it? It's a Dell Latitude something. It's a gaming laptop. I don't even know where the covers are because it was opened outside. Let me check. Okay, so it's an Inspiron 155577. So it's a gaming laptop with Core i7, I think. Core i7 7th gen. So this is what the laptop is doing. I'm gonna plug it in and power the device on. Let's switch it on and have a look at its behavior. So the power button is right over here and I think it's on now. Okay, yeah, it is on. So you'll see the Dell. The AC adapter wattage cannot be determined, the battery may not charge, blah 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 blah. Yeah, so this is with an original 65 watt Dell charger. So this is an original Dell 65 watt charger and it's the one that's saying it cannot be identified. So I'm going to use this. This one it's on 180 watts, a replacement charger. So it's not an original charger, but it's from my gaming laptop. I'm going to power it on. The one that I use at home actually. So I brought it to work today and thought I was going to use it, but I did not. So the AC adapter again cannot be determined, blah 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 blah. Alright, so at this point we already know it is a hardware issue. So as I had mentioned, I was already working on this. So I'll be quite honest with you guys, I've already figured out the issue with this, but I've put back the components as they were before I started working on this. So as I mentioned before, this came from a local repair shop just down the road. So it had already been worked on. Yeah, the guy says he went to one technician who's also around and they told him to change this IC, which is the PQIC. After changing the PQIC, still the laptop cannot charge. Actually, according to him, it was not switching on from the battery at all. So he gave me both the laptop and the battery. I plugged the battery to the analyzer and I discovered that the cells were too low. So the battery was locked. It needed to first boost the cells, then unlock the battery. So that I've done and I've tested. The battery works. It's already done. So now it comes to the part where the laptop can charge the battery when it's on. So yeah, you can see there is a lot of flux residue over there. So the guy really did work on the device. So I'll try to zoom in closer there. Okay, so you can see there's been a lot of carnage there. The guy was really busy on this. Yeah, so as I've mentioned already, this has been changed, the PQIC. So what I did is I first inserted a needle here into the charging pin, because remember you've got your negative and your positive, then you've got your PDID here. So this is the central pin there is the one that identifies the charger. So if I put this into beep mode, the multimeter into beep mode, and check for continuity from the charging port to the motherboard, I do have continuity there. So that was the first thing that I did when I started working on this laptop. First, check if the charging port was okay. So I'm not going to check negative and positive because the laptop is switching on, which means those are already sorted. But since it cannot identify the charger, so I started there. Because he also mentioned that he worked on the DC jack. That was the initial issue with the laptop. And still, the laptop is now on but not charging. Anyways, so from there I didn't want to work blind. So I went straight to Telegram, downloaded the schematic and the board view of the device. And this is how the schematic looks like. So I'll be like OBS. Let me use OBS because it's going to allow me to capture the two screens at once. Okay, so just give me a minute while I set up. Alright, so this is what we have got. So that's the schematics and the board view right on top of the other. So yeah, so you can see on the schematics I had already zoomed to where the issue was. So this is basically our DC inject CN11 CN11, so that would be the name right on the motherboard. Somewhere over there, there's a viewer who also asked me to work using a schematic diagram, so I'm gonna do that. So you can see CN11 there. So that's what I went and searched for on the schematic, and it brought me here. So you can see the first 1, 2, 3, 4, 5, 6 pins are ground, and then when you come to 1, 2, 3, 4, 5, 6, these are positive. So these are okay. We're not gonna bother ourselves with those. We're gonna bother ourselves with this one, the PDID. So the reason why it shows you as A5B5 is that according to the board view, if you look at the board view, yeah, do this. So on the board view here, if you look, you've got on either side. So it'll be like this, like that. So it'll be connected this side and that side, this side and that side. So that's how it is. That's why it shows you as two things, and now it looks like it's a lot of cables when it's actually just a few. Anyways, so the cable that we're looking for, it's number 5, which is our PSID. So if you look right over there, here it says plus dock PSID. So that's the one which we are working on. It also shows there on the net dock PSID. So as we zoom in on it, so from pin number 5, we're supposed to come to EL14. So I'll go to EL14 and check if we do have continuity over there, and we'll be. So that's what I did actually from the DC in check. Let's zoom in even closer. I'm not so sure if it's gonna be really clear, but I hope it will. No, I think it's okay at a distance like this. You can see enough. Until that microscope gets here, we'll work with this. So from the PDID over there of pin number 5, so you can see there's an inductor, another inductor, then a cap, and there's empty slots there. So according to the board view as well, it's inductor, a cap, and then comes our inductor which we're looking for, which is EL14. So when we go to EL14, we have continuity to here, but we do not have continuity on the other side. Reason being, EL14 was removed from the motherboard. So I think while the guy was working on this, he removed EL14. So what I simply did was I made a solder block over there. I could have simply used a jumper wire, but it won't make a difference at all. So I simply made a solder block to join the two sides. And so after doing that, now I have continuity on either side. So what I did is I went on and I tested the device, and Surprise, surprise. Let's test it and see. So yeah, I'm gonna plug the LCD. I think I could actually work without plugging the LCD. Yeah, I could just use display capture. I think I've got an HDMI cable here, an HDMI port. So yeah, let me just do it for now, and then the next time I'm gonna use display capture. That way I won't even need to keep this with me. And here's the charger plugged in, and when we power on the laptop, so you can see Dell over there. The AC adapter wattage cannot be determined, so we still have the same issue. So when I recorded the video about the PlayStation 5, this is where I was. No, this I had already passed this stage. So let me just test this and see if it displays without the LCD, and see if I can just use the HDMI display capture. So I'm gonna limit the number of things that I work with here on the desk. So let me plug an HDMI cable to this guy. Charger. Let's add another display capture. It's gonna be a video capture device, not display capture. Okay. Okay, so there we go. Now I'm gonna power on this laptop. The charger is plugged in and all is ready and set. So here we go. I don't have the fans plugged in, and the LED is actually on the side. So there we go. You can see Dell over there. The AC adapter wattage cannot be determined, blah 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 blah. Okay, cool. So we still have the same issue. So I'm gonna unplug the charger, and it goes off there. Okay, let's shut off this. This is nice. Anyways, so we are back to the board view. On the board view now, so now we've managed to establish the connection from here to EL14. So from EL14 we can see this is a cap, so we don't care because it's in parallel, the other side is ground. We come to PD2, we do not care because the other side is also ground, so it doesn't really affect anything. But from here now we come to PR193 as well as PQ29. So if we come to the schematics diagram here, according to the schematic diagram, let me bring up the schematics. Okay, so let me try to zoom it a bit. Cool. So according to the schematic diagram now, when we move from EL14, we should come to PQ29 and then go out of PQ29 via PR2L2 all the way to PSID. So our circuit comes from this way to PQ29, then it's out via pin number 1 here. So we've got pin number 3, pin number 2, then pin number 1. So from pin number 1 it goes out to PR202. From out of that we then go to PSID. So let's go back to the board view and check that out. So according to the board view, when we come from this, when we come to PQ29, we go out of pin number 1 and then we go to PR202. From PR202 now we have PSID. There it is. Now it exists. So this is now going to your EC chip, I believe. It's now, yeah, it has to go to your EC chip or something like that. Or it will probably go via one more thing. Yeah, now it goes to your EC chip straight. Here it is, by the EC chip. So once it's now PSID, now it's going to the EC chip. Anyway, so when it was still over here by PQ29, so what I did is I checked for a short circuit there before doing anything, because on the previous videos that I've done of this problem, you probably noticed that almost all of them, they had a short circuit along the PSID circuit. So what I did is let me bring it in the same orientation as the board view. So what I did is I checked right over here, so we do not have a short on our circuit. Even on the output we don't have a short. But then for some reason I just decided to check around where we've got PR193 here, and when you check this side of PR193 is okay because it's the one that's connected to PQ29. Oh no, it's not focusing. So as I was saying, this side of PR193 is okay, but when we check on the other side of it, we've got a short. And if you check the resistance to ground there, 0.2, that is a dead short. So we do have a short on this side of the PR193. So checking according to the board view and the schematic, this isn't supposed to be ground. So the only places that it's going to, it's going via PR186 and via PQ28. So it's either the short is coming from here because this side it's ground, or the short is coming from here because P number 1 is ground. So this was probably easier to remove because it's close to where my short is, but then it's smaller than PQ28. PQ28 was pretty easy to remove, so it was a trial and error. One of the two is the culprit, so I went with the easiest one to remove because it's big. So I removed PQ28 from the circuit, which is this guy over here. So we're going to do that. Yeah, the board is really tight. Let me just try to clean it up with some alcohol and toothbrush. If you look at the liquid coming from the board, it's really brown. That's how dirty it is. Okay, so I'm removing PQ28, which is this guy over here, right behind PQ29. So because we're looking for the culprit that's bringing the short circuit to this. So I'm pretty sure the inductor over there did not just disappear, EL14. At this point, I am convinced that the guy actually removed it. Come on, this is a really small component to remove. Anyways, with PQ28 gone, we can then check for the short circuit. If it's still there, then our short circuit is coming from PR183 because it's also got a direct link to ground. So checking that out, our short circuit is gone. We no longer have a short circuit on PR193. So with this, I then replaced the PQ28 with another component, which is this guy over here. I reduce the airflow because this is a really small component and it can be blown to the 9th dimension easily, and you shouldn't even bother looking for it because you won't find it. If it's big components, it's really easy because you can listen to, oh, the heat is not at maximum. So basically I'm not even doing anything. Number one, the heat is not at maximum. Number two, the nozzle is very big, which is making the hot air pretty useless. Okay, cool. With that there, I'll just solder it a little bit to do some touch up. To make sure it doesn't go anywhere. So we've replaced PQ28 to remove that short circuit. So this side it's ground, and this side it should not be ground. So now we're okay because we've got like 14.44 kilo ohms resistance. So that should give us some confidence in our solution. Anyways, I was very convinced that I'm done with this. So yeah, when I did that PlayStation 5, like this is where I was. Because remember I mentioned that I've been removing components from the motherboard and all that, but still I do not seem to find a solution to the problem. So I'll bring the charger once again, and let's turn on the display capture. No, not this one, but this one. Okay, so I'll power on the laptop. And you will be surprised. The AC adapter wattage cannot be determined. Blah 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 blah. Yeah, I was very disappointed at this point. I decided to take the PlayStation 5 and fix it. So with this, I've managed to eliminate the short circuit in that area. I've managed to also connect the missing inductor there, but still the issue is it's still there. It's not going anywhere. So what I then did from there is I started probing around, checking around those components and following actually the circuit, because at this point I was convinced I am done with this. I was pretty confident that I'm done with this area. So let me go back. So I was pretty confident that I was done with this area since the short circuit was already fixed. So I went back to this, and according to the schematic, remember we go to pin number 1. So let's bring up the schematic. So on the schematic it clearly says we go to pin number 1 via PR202 we go out. So I did check these resistors actually. So this one is giving us a 15 kilo ohm resistance, and this one is giving us a 65 kilo ohm resistance. But if you remove it from the motherboard, it gives you a 100 kilo ohms. It's like 99 kilo ohms or something like that. So the resistors were okay. So I'm gonna measure those resistors just for sanity check. So remember, this side is ground, and that is this one over here, PR186. So you can see on pin number 2 we do have ground. Okay, let me remove that light. So if you measure there, you can see we do have about 13.57 kilo ohms. And then if you measure the other one, we do have 36. Actually it's 60 something. I think it's because the board is a bit hot or something like that. Anyways, there was no issue over there, so I continued and I came straight to PR202 because that's the only culprit that I can think of. PQ28 has already been replaced. PQ29 is okay because we do not have a direct short, we don't really have a short circuit between any of its probes, any of its pins. So you can see none of its pins have got a short circuit. So there was no reason for me to be replacing PQ29. This one is just a cap, and it's okay because we do not have any ground over here. We've solved that ground issue by replacing PQ28. whereas PD2 does not exist. It's not even there on the motherboard. So after continuing, I came to PR202. So PR202 is supposed to be a 33 ohm resistor, and lo and behold, actually this was put a bit slanted to the side, so I made it straight, but anyways, that is gone already. So PR202 is right over here according to the board view. I'm gonna go back to the board view. So according to the board view, from PQ29 come to PR202, which is this guy over here. So we've got its input and its output going now to PD1. Its output is the one that gives us PSID. So what I did is I checked for a short circuit first on its output, which I didn't expect to get because it's just a 33 ohm resistor, so it's not really different from a fuse. There is a bit of resistance, but it's not really a lot. So I checked the resistance on it, and lo and behold, the resistance is in the kilo ohms. Yeah, that is a lot. So for a device that works with really low voltages, this is a lot of resistance. So what I did is I just put a jumper wire on it. Let me grab my jumper wire. My laptop is almost empty on the battery, so I need to be quick. I will cut the long story short. So I put a jumper wire over there. There we go. So I'm gonna come to pin number 1 of PQ29 and this side. So now we do have a continuity. So all I simply did was connect from pin number 1 here to pin number 2 of this. So I've simply jumped this, and if we plug a charger now, now racing against time so that my laptop doesn't shut down. I don't have a charger right now. My work laptop. Okay, where is the tweezer? There's a tweezer. So now if we power on the device, let's go back to this video capture, Dell, and look at that. Now we're okay. Now we are fine. So now it just says hard drive not detected. Let me plug a keyboard to it and go to the BIOS. It no longer talks about AC adapter not being detected. So I'll say Ctrl Alt Delete, and then I'll press F2 to get to the BIOS. So if you look over there now, what does it say? AC adapter type 180 watts. So with that, the issue has been solved. So this was a roller coaster of a repair. It took me a bit of time because of all these issues. So first of all, the inductor was missing. Second, we had a short circuit in the whole, it's called a potential divider, in the potential divider of the PSID circuit. And then next to that, we had an issue again with the resistor being dead, as well as that MOSFET, which was that PQ28, this one, which was dead. So I hope you guys learned something, and for those that needed to see a video of how to use a schematic and a board view, I believe this is enough. So there you go, 180 watts, and the laptop has been fixed. Thanks for watching, guys, and I will see you in another video. Cheers.